Review of exponent laws. Powers are comprised of a base and an exponent. So we call this a power. A to the n is the power, right? The base is a and the exponent is n. Radicals are comprised of a radicand, an index, and a radical sign. So this is the radical sign, usually a square root if there's nothing written in here. If it's another root, like a cube root or fourth root, you'll see a number that's called the index. So no index means the square root. And the radicand, which is the thing that you are taking the root of, goes under the radical sign. Okay? And this language of bases and exponents and that will be covered over the next 2 units, right? Both exponents and logs, or logarithms. So description, product of powers. Okay, so remember this whole thing is called a power. So when you multiply powers with the same base, what do you do with the exponents? You add them. So this is a to the m plus n. So 3 squared times 3 to the 4th is?
3 to the 6th.
Yeah, so 3 to the 2 plus 4, which is equal to 6. 3 to the x times 3 to the 4 minus 2x. So it's going to be x plus 4 minus 2x, which works out to 4 minus x, right? Because you're adding the x, so you got x minus 2x is negative 1x. And, you know, we could write it as 4 minus x. We could write it as negative x plus 4, okay? So it could be either way. Quotient of powers, division. A to the m divided by a to the n is equal to? So when you're dividing powers with the same base, you do what with the exponents? You subtract the exponents. 6 to the 8th divided by 6 squared is? Which is 6 to the 6th. 6 to the 8x squared divided by 6 to the 2x. So we've got 8x squared minus 2x. Really, that's it. That's all you can do, right? That's all you can write. Is 8x squared minus 2x, right? Keep in mind, we are dividing powers with the same base. We subtract the exponents. Power of a power. If you raise a power to a power, what do you do with the exponents? Multiply. So this is a to the m times n. Okay, and times can be denoted by an x, can be denoted by a dot, could be denoted just by writing the 2 letters together, mn. So 3 squared to the 4th is? Yeah, so 3 to the 2 times 4, which is 3 to the 8. So always remember where it came from, right? Because that helps you when you're looking at something like this where, yeah, it's not really obvious what it is, right? I mean, this, you go, oh, 8 minus 2 is 6. But here you're going, oh, it's 8x. What is it? It's 8x squared minus 2x. 3 to the 2 to the 4 plus x is? 3 to the 8 plus x is wrong. Yeah, so it's 2. So in this case, 4 plus x is an expression, right? And so it needs to be kept in brackets. So it's 3 to the 2 times 4 plus x, which is 3 to the 8 plus 2x. Okay, so watch out for that. Send them up to grab some stuff. Sheets on the desk there. Power of a product. So if we have a product.
Right there.
Are there sheets and are they on the desk?
Oh, found it.
Usually, I did it last year. I'll put them on a chair here. I should have done that. I'll stick them on a chair, blocking the way, so you actually have to walk around the chair. You can't even just sort of squeeze by it, right? And people just walk right by it, right? And I'll have sheets on it. Yeah, but they'll ignore that.
This was a little harder bit of a test, right? It's like identify the white pieces of paper on the desk. Power of a product. So a times b to the m. What do we do with that? Yeah. So it's a to the m times b to the m. Okay. So you raise each part to the power, and then you take its product. So 2 times 3 cubed is 2 cubed times 3 cubed. Right, now we can evaluate some of these, right? You could just go, oh, it's 8 cubed, which is, of course, obviously 512, but, you know, in this case, we're really just worried about the expansion. Because now you get 2 times x to the 4th, which is, yeah, 2 to the 4th times x to the 4th, which will, of course, become like 16x to the 4th. Now, I mean, what often happens, the common mistake is everybody knows it's x to the 4th. They forget to do the 2 to the 4th, right? So they say, oh, it's 2 times x to the 4th. Then you get 2x to the 4th, which would be wrong. Power of a quotient. A over b to the m is a to the m over b to the m. And b cannot be 0 because you're not allowed to divide by 0. So 3 over 4 cubed is 3 cubed over 4 cubed. Okay, and again, we could evaluate that, right? It's going to be 27 over 64, but yeah, we'll leave it in that form. I mean, it's pretty trivial to work that out if you have to. X over 4 cubed is x cubed over 4 cubed, right? Which would be x cubed over 64 if you were going to evaluate it. 0 exponent. A to the 0 is equal to 1. Anything to the exponent 0 equals 1. So sometimes you get a really complicated expression and you're like, oh, there's so much stuff, but it's raised to the exponent 0. Right? In which case, don't look at it and say, oh, I got to work all of this out. It's like, no, whatever's in here raised to the 0 is just going to be 1. Okay? Sometimes it helps to look to the bigger picture. So 6 plus 1 to the 0 is 1. Right? Anything to the 0. 6 plus 1 is really 7. It's 7 to the 0, but you don't have to evaluate that, right? You can just say it's something raised to the exponent 0, so it's 1. X squared plus 1 to the 0 is 1. Okay, again, same deal. Oops, where'd that go? Negative exponent. A to the negative n is equal to 1 over a to the positive n. So if we're going to express things with positive exponents, we need to take the expression with a negative exponent, and if it's by itself, a to the negative n, we write it as 1 over a to the positive n. And if it's in the denominator, if you have 1 over a to the negative n, then it moves. So, you know, if it's by itself, it goes into the denominator. If a negative exponent is in the denominator, it flips up to the numerator, and the exponent becomes positive. 5 to the negative 2 is 1 over 5 squared, right, which could then be evaluated as 1 over 25. X to the negative 2 is 1 over x squared. So a lot of times we'll say, express your answers with positive exponents. Okay, so if you get a negative exponent, you have to change it. Okay, let's keep doing that. A to the m over n. Fractional exponent, what does that do? So it's the nth root of a to the power m. Or it's the nth root of a it's the nth root of a raised to the exponent of m. If you're doing it without a calculator, this is a lot easier to do, right? Find the root. So it was like the cube root of 20 If this was like 27 to the 2/3, you'd say it's the cube root of 27, which is 3, squared, which is 9, right? Which is easier than doing the cube root of 27 squared. It's like, what's the cube root of 729, right? It's, you give me a calculator to work that out, right? So 9 to the 3/2 is? It's either the square root of 9 cubed, or it's the square root of 9. Not even a 2, I don't know where that came from. It's the square root of 9 cubed, which is 3 cubed, which is 27, right? And you can work this out a lot easier than you can work this out. 9x to the 3/2 will be what? Well, it's power to a product, so it's 9 to the 3/2 x to the 3/2. Right? That can be evaluated, right? And we'll worry about that in a minute, because we'll be doing a bunch of those in a little bit. Okay, so those are the exponent laws, right? Which you need to be familiar with. And now we can do stuff, simplify, express answers with positive exponents only. Just trying to move the frame a bit. There, better. Okay, so p to the 4th times p to the 10th over p to the 11th is. So what are you going to do? You're going to add these exponents. Gives you p to the 14th over p to the 11th, which is p to the 14 minus 11, which is p cubed. Okay, now, you might do that in fewer steps, but this is just showing you the full details, right? So what's going on here? Well, all right, so we've got multiplying powers with the same base. We've got to add the exponents, right? So it's p to the 4 plus 10 over p to the 11. 4 plus 10 is 14. I got p to the 14 over p to the 11. Okay, we are dividing. When we divide, we subtract the exponents. 14 minus 11 is 3. The next one, we have numbers. So what's negative 48 divided by 6? That would be negative 8. What's d to the 5th divided by d to the negative 2? Okay, when we divide, what do we do with the powers? We subtract them. So it's going to be 8, negative 8. Okay, so the 48, negative 48 divided by 6 is negative 8. D to the 5 minus negative 2. So final answer is negative 8. D to the 7, right? 5 minus negative 2 is 5 plus 2 is 7. So no, I wouldn't make it not negative. I would not make it positive either, because that's not negative. No, so here's the thing to remember. It's negative exponents that we want to change to positive exponents. Negative numbers are negative numbers. Nothing you can do with them, right? They are what they are. If they're multiplied by a negative, they will become positive. If they're being subtracted, we will turn it to a positive. Its negative exponents can be made into positive exponents by simply moving it from where it is to where it isn't. If it's in the numerator up top, move it to the bottom, the negative exponent becomes positive. If it's in the denominator as a negative exponent, move it up top to the numerator, it will become positive. If the number is negative, don't change it. Okay? And you're going to, right? I'll tell you right now. It's going to be like these big X's through stuff because, you decided that, oh, it's a negative 8, so I'll just put it as 1 over 8. And I'll say, no. Well, I mean, you can do that, but it's wrong. Then you go, what's wrong with this? It was negative. It's not the exponent that's negative, it's the number that's negative. Okay, so only negative exponents can be made positive. Okay, what's 5 times negative 2? Negative 10. Will we change that to 1 over positive 10?
No.
No, because that would be silly, right? I mean, if I wrote negative 10, if I wrote this, you'd go, are you nuts? Right? I mean, that's like 1/10. That's 0.1. How is that anywhere near negative 10? So So we take the number, so I've got negative 10 x to the, now what do I do with the 3 halves and the 5 halves? We're going to add them, right? So we're multiplying powers with the same base. So what's 3 halves plus 5 halves? 8 halves. What's 8 halves? 4. So write it as a 4. Don't write 8 halves. Okay? If it can simplify, don't give me a non-permissive value and say it's 15 over 3. Right? I'll just mark it wrong. Yeah, no, it's 5. I don't care if they're the same. Right? I want the simplified form. All right, let's keep going. 5p to the 4th to the negative 2. So what's that going to be? Yeah. So it's 5 to the negative 2, right? P to the what? It's power to a power. What do you do with the exponents? Multiply them. So what's 4 times negative 2? Negative 8. But we want to write these with positive exponents. So it's 1 over 5 squared. So the 5, the negative 2, the negative exponent changes to positive by moving it to the denominator. The negative exponent changes to positive by moving it to the denominator. And 5 squared is 25, so we're going to write this as 1 over 25p to the 8th. Okay, what do we do with the next one?
Multiply.
So it's power to a power, we multiply exponent.
Negative 2x 6 times x to the 9.
So that negative is inside the brackets, right? So it's the negative 2 that's going to be raised to the exponent 6, which is going to make it positive or negative? It's going to make it positive, right? So a negative value, not negative exponent, a negative value raised to an even exponent, right? Just think you're going to pair off the negative signs, right? So you multiply negative 2 by itself 6 times. So you got a pair of negative 2's, can be positive, get another pair, get another pair, you got 3 pairs. And those negatives will pair up. Okay, so what's negative 2 to the power of 6? 64. What's x to the 3 halves to the 6th? What? What's 3 times 6? So write the 6 as 6 over 1. What's 3 halves times 6? 18 over 2, but we don't want to say that. What are we going to say?
I said 9 the first time.
I know.
You're like, what was that?
I'm not waiting for you. I want other people to come to that conclusion as well. It's not just, it's not about you.
All of them.
Okay, so 3 halves. Feel free to use your calculators, right? It's not like they take them away and say the first half of the diploma is without a calculator. They're always there. Okay, so go 3 halves times 6. You know, your calculator should say 9. Negative 4, a to the negative 2 cubed. Okay, how are we going to split that out? So we can't multiply negative 4 times 8, right? Because order of operations says you got to do that cubing first before you can multiply the 2 sets of brackets. Okay, so what do I do with the negative 4? Cube it. Sounds very biblical. What do I do with the a to the negative 2? Also very biblical. You cube it, right? Which is the distance from your elbow to the. What do you do with the a to the 7? Cubit, man, the arc. How many cubits long was the arc? You know, God told us to build an arc and make it so many cubits. A cubit is a measurement of distance from the tip of your elbow to the middle finger.
And he said it's 3 cubits.
Anyways, so what do we do? Negative 4 cubed is negative 64, right? When you raise a negative to an odd power, it stays negative. Okay, so we got negative 64. We've got a to the negative 6. We've got an 8. And we've got an a to the 7th. Oh, I might as well throw everything in brackets. So number-wise, we've got negative 64 times 8, which is negative 512. You can use a calculator. It's okay.
Wait, why is it? Where did you get that?
Because 64 times 8 is 512. A to the negative 6 times a to the 7th is a to the...
A.
It's just a.
It was A to the A, we'd be talking.
Yeah.
No.
So the a to the a be a to the a. A times itself 8 times. So it's negative 512. Okay.
Yeah,
That's a Canadian question again.
No. Oh, wait. That's it?
That's it, eh?
Okay.
Ah. You evaluate each of the following without a calculator by converting each to radical form and then simplify. Okay. Now, yeah, we are not going to withhold calculators, so you know. Trust me, I will not take away your calculator. Now, if you don't have batteries, I might not loan you one or something. It's been saying for. Okay, so an exponent of a half is a square root. Okay. So this is the square root of 16, which is, I'm going to go with 4. You should too. It's okay, you can actually use calculator, I promise. Look, cross my heart.
Wait, if you type it, please.
Okay, 64 to the negative a half. So first we got to change negative exponent to positive exponent. So what's this going to become? 1 over 64 to the positive a half. Now we're going to change it from exponential form to radical form. So that's 1 over the square root of 64, which is, Emily, you can pull it out now. 1 over. Give me the same answer you gave me last time.
Oh, 8.
Right. This thing, now is the time for 8. You're just one question too soon. Okay, so 64 to the negative half is 1 over 64 to the half. Panthers acquire Yarmer Yager for a 2015 second round pick, a conditional third round pick. It's just a notification that popped up. 125 to the 1/3. What kind of root is 1/3? Cube root. What's the cube root of 125? 5. Good. Didn't even have to clue you on that. You knew that. Good. 27 to the negative 2/3. What's the first step? 1 over 27 to the positive 2/3. What root is it? So it's a cube root of 27. Now, it's easier to do the cube root of 27 and then square that, right? So you can do the squared on the outside, or you can put the squared on the 27, and you know, if you're using a calculator, which you can always use, it's not going to make any big difference. But what's the cube root of 27? 3. So this is 1 over 3 squared, which is 1 over 9. If you use your calculator and you go 27 to the power of, which is an upside down v, which is known as a caret, and then you go negative 2/3, it'll give you 0.111111111. You go math, enter, and it'll convert it to 1/9 for you. Okay? So you can always use your calculator. You can just type 27 to the power of negative 2/3. It'll give you 0 point and a whole bunch of ones. And you go math, enter, and it'll change that to 1/9. Okay, so 16x to the 4th to the half. Do you just want to say the answer? I mean, we don't even need to. Do we need to do a lot of work on this, or do we just want to go?
We need to do a lot of work.
You're close, but you still haven't figured out the square root of 16.
That's embarrassing.
All right, so obviously we need to break this down. So it's 16 to the half. Okay, so we've got product of a power, right? Which means we take each individual part of the product. So it's 16 to the 1/2, x to the 4th times 1/2. Power to a power, you multiply exponents. 16 to the 1/2 is the square root of 16. And x to the 4 times 1/2 is x squared. Square root of 16, despite your best efforts to change it, is still 4. And x squared is just x squared. Now, there's a little trick we can do with one of these guys. When we have a quotient to a negative, here's how we handle it. We say, what I'm going to do is just flip this, and then I can change that to a positive. Okay, so instead of going 64 to the negative half over x squared to the negative half, you just say, hey, if I have a quotient to a negative exponent, I flip the quotient, and then I can change the exponent to positive, right? Because what's on the top is now on the bottom and vice versa. That's what a negative exponent does. Take whatever on the top, put it on the bottom. So we've done that, make the exponent positive. So now we got x squared to the half, which is x, and we've got the square root of 64, which is 8. So it's just x over 8. 125x to the 6th to the 1/3. So it's going to be 125 to the power of 1/3. X to the 6 times 1/3, if it helps, right? The 6 is 6 over 1. This is the cube root of 125. This is x to the power of 2 squared, x squared. Cube root of 125 is? And we get 5x squared.
Is
Okay.
this gonna be on the quiz tomorrow too? It's not tomorrow.
No quiz tomorrow. See what happens when you come in. Miss the news. It'll be Monday instead. Or Tuesday, I don't know. Monday or
How about
Tuesday.
Tuesday? Tuesday's better.
Fine, it'll be Tuesday. It'll just cover more stuff then.
Oh.
Okay, 27x to the 9th to the negative 2/3. So 27 to the negative 2/3. X to the 9 over 1 times negative 2/3. Okay, so it's product to a power, right? So you raise each individual part of the product to the power. 27 to the negative 2/3 becomes 1 over 27 to the positive 2/3. 9 times negative 2/3 is? Which is? So it's negative 6. So this is 1 over the cube root of 27 squared, and then the x to the negative 6 moves down to the denominator where it becomes x to the positive 6. Cube root of 27 is? Squared is? So it's 1 over 9x to the 6th. Okay, right. The idea here is just to get you used to looking at the exponents, thinking about these exponents. Express each of the following as a power. So this is changing from radical form to exponential form, right? You got a square root. X, square root of x is x to the power of. What's the square root? That's 1/2. Cube root of 5 squared is 5 to what power? Okay, 2 over 3. So remember, with a rational exponent, the denominator is what root, and the numerator is what power. Anybody leave a pair of glasses in 302 the other day? Nope. Okay. 5x over 4th root of x cubed.
It's 5x times x to the negative 3/4.
Well, let's do it a step at a time. So 5x, what's the exponent? So 4th root of x cubed is x to the 3 over 4. So 5x times, so we're just doing, that's power of 1, right? So quotient, we subtract powers. What's 1 minus 3/4? 1/4. Right. So it's 5 times x to the 1/4.
Wouldn't that be a half?
No, it would be a quarter. 3/4 on the bottom. It's 1 minus 3/4.
Wait, isn't it?
You have a loonie, I take away 3/4, you have 1/4 left.
That's very.
Sorry, you have a loonie and you make change, now you have 4/4, I'm taking away 3/4.
Wait, how did you split it like this?
I just did 1 minus 3/4, feel free to use your calculator to do that. Right. Write each of the following, and okay, so now, this is actually important. I don't say that often, right? But this actually is important. There will be questions that involve this. So write each of the following as a single power with a base of 2 or 3. So 32 can be written as 2 to the something or 3 to the something. So what's 32? Is it a power of 2 or is it a power of 3? It's even, so it has to be a power of 2, right? So use your fingers, 2, 4, 8, 16, 32. So 32 is 2 to the 5th. Got 2 cubed times 4 to the x. Now, can we express 4 as a power of 2? So what's 4 if you're going to write it as a power of 2? So this is 2 cubed times, so instead of 4, we're going to write 2 squared to the power of x, right? Because it's 4 to the power of x. So we're writing that as 2 squared to the power of x. So let's simplify this first. What's 2 squared to the power of x? Okay, so we multiply, right? Power to a power, you multiply, so it's 2 to the 2x. So we got 2 cubed times 2 to the 2x, which is multiplying powers with the same base. What do you do with the exponents? So it's 2x plus 3. Okay, so we're going to be doing a bunch of this stuff. We're changing powers to the same base so that we can solve problems. It's easier to do. There's other ways to solve those problems, but remember one of the tactics they use on the exam is just to show you, here's a partial solution to something. Is there a mistake in there, right? Or which step is the mistake? 16 to the 3/4. How do we express 16 as a power of 2? 2, 4, 8. So 16 is 2 to the 4th, right? So instead of 16, we write 2 to the 4th. It's being raised to the power of 3/4. Instead of root 8, What's 8 written as a power of 2? 2 to the 3, right? So it's 2 cubed. What's a square root as a power? So I want to change root in, so it's 1/2. So it's going to be 2 cubed to the 1/2. Okay, and then all of that, because this 2 cubed to the 1/2 is just this, right? Square root of 8. All of that is being cubed. So 2 cubed, that's how we're going to express 8 as a power of 2, right? So 8 gets written as 2 cubed. Square root of 8, well, it's 2 cubed to the power of 1/2, right? That's 8 to the 1/2, or square root 8. And it's supposed to be the square root of 8 cubed, so now we've got 2 cubed to the 1/2 cubed. All right, what's 2 to the 4th to the 3/4? So power to a power, what do we do with these exponents? Multiply them. What's 4 times 3/4? I have 4/4 and I want 3/4. Got to learn to make change. What's 2 cubed to the 1/2 cubed? Power to a power to a power, what do you do with the exponents? What's 3 times 1/2 times 3? Okay, what's 3 times 3? What's the real 3 times 3? 9 times 1/2 is 9/2. So it's 2 cubed times 2 to the 9/2, right? 3 times 1/2 is 3/2, times 3 is 9/2. What do we do with the cubed and the 9/2? Multiplying powers with the same base, what do we do with the exponents? Add. So it's 3 plus 9/2. Okay, I'm not going to write 3. I'm going to write 3 as 6/2. That's what it is, right? 3 is the same as 6/2. So now I got 6/2 plus 9/2, which is 15/2. So this is 2 to the 15/2. Okay, so write each one. It's a single power now with a base of 2 or 3. In this case, a base of 2. So it's 2 to the 15/2. And we're just going to leave it like that. Now it's a single power. 1/2 to the x times 64 to the x minus 3. What's 1/2 written as a power of 2? It's 1/2 to the 1. So let's say I take a positive exponent on the bottom, which is 2 to the 1, and I move this up top. So what happens if I move a positive exponent up top? It's going to become a negative exponent. So this is going to be 2 to the negative 1 to the x. Right? So 1/2 is 2 to the negative 1. What's 64 as a power of 2? Yeah, we already did this, right? It's 6. And then that's raised to the x minus 3. Throw brackets around the x minus 3 just so you remember to distribute. So what's 2 to the negative 1 to the x? Well, power to a power, multiply the exponent. So it's 2 to the negative 1 times x, or negative x. And we've got 2, so this will be times 2 to the what? Let's break it down. So let's just go 6 times x minus 3. So 2 to the negative x times 2, what's that work out to? 6x minus 18, right? Final answer is 2 to the 5x minus 18, right? We've got multiplying powers with the same base. You add the exponents, so we get negative x plus 6x, which is 5x, minus 18. So 2 to the 5x minus 18. Okay. Question? Let's see what's new. We did a whole bunch of powers of 2. Let's do powers of 3. So 1/27. What's 27 as a power of 3? 3 to the 3, right? So it's 1 over 3 cubed. Okay, now we could write that as 3 to the negative 3, right? Generally we like to write things with a positive exponent, but you could also see this written as 3 to the negative 3. Okay, and if you do, then you say that's 1 over 3 cubed, which is 1 over 27. What's 243 as a power of 3? 3 to the 5th, right? That's helpful. If you can recognize powers of 3 up to about 243, right? It's just kind of handy. At the very least, recognize 243 as a power of 3. So even if you don't know which one it is, you know that I can find which one it is. So 243 is 3 to the 5th to the x minus 2, which is 3 to the 5 times x minus 2. So make sure when you're doing this that you multiply both of them, right? That's really the key to this stuff here, is that you don't get like 5x minus 2. That's what a lot of people will do here, is just go, oh, it's 5x minus 2. And it's really 5x minus 10. Okay, so it's 3 to the 5x minus 10. What's 9 as a power of 3? Sure, sounds easy, but nobody's exactly shouted out. It's 3 squared. Oh, okay, 3 squared. Over 3 to the x plus 1, right? I mean, there's nothing really to do on the bottom here. We got to simplify the top first. So what's 3 squared to the negative x? Simplifies to? I can wait. Take 5 seconds for this thing to clear. So, okay. I'm ready. What's 3 squared to the negative x? Power to power, what do you do with the exponent?
You multiply.
What's 2 times negative x?
Negative 2x.
Negative 2x. Thank you. 3 to the negative 2x over 3 to the x plus 1. Okay, when you divide powers with the same base, what do? You subtract. So it's negative 2 minus x plus 1. Got to write the x plus 1 as a quantity in parentheses, right? Don't just go negative 2 minus x plus 1. Write it down without the parentheses. Okay, now you can remove the parentheses, get negative 2x minus 1. So that's the big deal here, right, is that it's minus x minus 1, that's distributed. So the final answer is negative 3x minus 1. Okay, so 3 to the negative 3x minus 1. Oof, all the way back to the top. 3 to the x minus 5, 1 over 81. What's 81 as a power of 3? 3 to the 4th, yeah, okay. So it's 3 to the x minus 5 times 1 over 3 to the 4th to the 2x, which is 3 to the x minus 5 times 3 to the negative 4. So 1 over 3 to the 4th can be written as 3 to the negative 4 to the 2x, which is 3 to the x minus 5 times 3 to the, what do we get here?
Negative 8.
Negative 8x, yeah, so negative 8x. So this is 3 to the, final answer?
Negative, never mind.
Yeah, negative.
Negative 8x minus.
Well, so it's x minus 8x, so how many x's are left? Negative 7x minus 5. Okay, so 3 to the negative 7x minus 5. All right, moving right along. Simplify the following, write as a single power if necessary. Okay, I'm not even going to ask you guys, right? I'm just going to work these, okay? So just watch, be amazed, whatever. 3 to the 20th, 3 squared. So I need to rewrite the 9 as 3 squared, right? And it's being raised to the negative 8, and then there's a 3 to the 5th on the bottom, and the whole thing is being squared. So really what I want to do is simplify the brackets first, and then at the end I'll just, whatever I've got left, I'm going to multiply by 2. So we have 3 to the 20th, 3 to the 20th times 3 to the negative 16, so 2 to the 3 squared to the negative 8, multiply, get negative 16, over 3 to the 5th. So 20 minus 16, right? So we're adding, right? It's 20 plus negative 16. So it'll be 3 to the 4th minus 5. So 4 minus 5 is negative 1. So this is 3 to the negative 1. And then that's being squared, right? This whole thing works out to 20 plus negative 16 is 4, minus 5 is negative 1. So we have 3 to the negative 1 squared, or 3 to the negative 2, which is 1 over 3 squared, okay, which could then be written as 1 over 9. So you might see an answer of 1 over 9. It says what though? Write as a single power if necessary. So 1 over 3 squared. Square root of 5 cubed. So it's 5 cubed to the 1/2 times 5 to the 1/2 over 5 to the 4/3, right? So we're just converting all of the radicals to exponential, right? So square root is a half, another square root is a half, and the fourth root of 5, the cube root of 5 to the 4th, root goes on the bottom, power goes up top, right? So 4 over 3. So this is 3 halves, power to a power, so it's 5 to the 3 halves times 1/2 over 5 to the 4/3. So 3 halves plus 1/2 is 4 halves, right? Because you're adding, multiplying powers with the same base. So 3 halves plus 1/2 is, let's say, 4 over 2 minus 4 over 3, right? Because then we're dividing power, so we got to subtract. So it's 3 halves plus 1/2 is 4 halves minus 4/3. In order to add or subtract fractions, I need a common denominator, which is going to be 6. So this becomes 12 over 6. And this becomes 8 over 6. And 12/6 minus 8/6 is 4 over 6, which reduces to 2 over 3. So it's 5 to the 2/3, or the cube root of 5 squared, cube root of 25, cube root of 5 all squared. Okay. You're generally not going to be doing stuff this complicated, right? But it's kind of a good idea to work a little above the level that's expected, so you can up your game a little. Solving equations involving exponents. So this is something that we kind of have to do, is solve an exponential equation. So if x squared is equal to 9, what value of x, or values of x, will satisfy the equation? So what we got to do is take the square root of both sides, right? So what's the square root of x squared? That's just x. What's the square root of 9?
3.
Plus or minus 3. Right? There are two numbers. So if x squared is 9, x could be positive 3, but it could also be negative 3. That's a little different from this. Root of 9 is just equal to 3, right? So if I write square root 9, because the square root symbol means the positive or principal square root only, right? So the radical sign here, this means the positive square root only. when we say something squared is equal to 9, then we get both solutions, right? We say, well, that thing, 3 squared is 9, but negative 3 squared is also 9. So there's a little subtle distinction between this and this. X cubed equals 8. Okay, there's only one answer this time. X is equal to 2. Okay. Now, there's a fancy way to solve this, so you could do it this way. Say, I got x cubed, but I'm going to raise it to a power so that this times this is equal to 1, right? So what 3 times what gives you 1? 3 times 1/3. Now, if I raise the left side of the exponent to 1/3, I got to do that to the right side. So I'm basically just raising both sides to the power of 1/3. This gives me x, and this gives me cube root of 8, which is 2. Okay, so that's one way to solve an equation involving an exponent, right? Is to raise it to another exponent such that it'll become 1. That's what we're going to do here. So I've got x to the 3/2. So if I raise it to the reciprocal of 3/2, right? If I just flip over the 3/2 and do this as 2/3, and do this guy here as 2/3, 3/2 times 2/3 is 6/6, or 1, right? So this just becomes x, and this guy is the cube root of 27 squared, which is 3 squared, which is 9. Okay? So we can solve this, don't need a calculator, which you may use, but you don't need a calculator. This one is x to the 2/3, so I raise it to the reciprocal, which is 3/2. If I do that to the left side, I got to do that to the right side. This just becomes x, right? 2/3 times 3/2 is 1. When you multiply reciprocals, you just get 1. This is the square root of 16 cubed. Square root of 16 is 4 cubed. 4 cubed is 64. This is x to the 2/5. What exponent are we going to raise it to? 5/2, right? So we raise it to the reciprocal. Do that to both sides. Left side becomes x, right? We set it up so that this would become 1. X equals, or x to the power of 1. This is the square root of 4 to the power of 5. What's the square root of 4? 2. Remember, this means the principal square root of 4, right? Not positive or negative. So 2 to the 5th, and so x is equal to 32. Okay, and I'll give you a moment to copy that down. There's a lot of exponents, right? It's going to take the whole class to get through this. That's okay. We got to review these exponents. Solve the following equations algebraically. Negative 2/5. So you raise to the reciprocal, which will be negative 5/2, right? If the original exponent is negative, the reciprocal also has to be negative. Which is equal to 4 to the negative 5/2. These two guys multiply to give you 1, so it's just x is equal to, this is 1 over 4 to the 5/2, right? Because we got a negative exponent, so we make it positive. We go 1 over. Bottom number is root, top number is power, so it's x is equal to 1 over the square root of 4 to the 5th, which is 2 to the 5th, which is 32. So x equals 1 over 32. This one, okay, it's a very important thing to learn here. Stop texting for one moment. When you get something like this, get rid of the 2 first. Okay, isolate the x before you do anything else, right? If you just try and raise this whole thing to the 3, it's just going to blow up in your face. So isolate the x first. So this is x to the 3/2 is equal to 64. Okay. So simplify it so you no longer have a number in front, right? Get rid of that number. Just divide both sides by 2. Now we can just go along with the 3/2 to the 2/3, 64 to the 2/3. 3/2 times 2/3 is 1, and this becomes the cube root of 64 squared, which is 4 squared, which is 60. $125, do the same thing, right? Do not try and take a power of this 125. Don't do that. Get rid of it. So x to the negative 2/3 is 5 divided by 125. So x to the negative 2/3 to the negative 3/2, right? Negative power has a negative, or negative number has a negative reciprocal, right? And you want negative times negative because you want it to be positive 6/6 or positive 1. And 5 over 20, or 5 over 125 becomes 1/25, and you can raise that to the negative 3/2. Okay, so this left side becomes x to the 1, or just x. And this guy, I can flip this and make it 25 over 1, and then change that to a positive, right? So it's just 25 to the 3/2, which is the square root of 25 cubed, which is 5 cubed, which is 125. So x equals square root 25 cubed, which is 5 cubed, which is 125. Graphs of exponential functions. All right, this is the stuff we actually have to learn. The other stuff was just preliminary. That was just get your skills with exponents, remind you how to do exponents and stuff like that, right? Because we got to be able to graph these things, so we got to know the exponent laws. An exponential function involves a power where the variable is part of the exponent. The basic exponential function is y is equal to c to the power of x, where c is a constant and c is greater than 0. Okay, so like y equals 2 to the power of x, y equals 5 to the power of x, y equals 1/2 to the power of x. That's what we mean by an exponential function, right? So usually we see stuff like y equals x squared, y equals x cubed, right? And in that, the variable is the base, and we've got a number for the exponent, right? We're supposed to know, what are the characteristics of a cubic? What are the characteristics of, x squared? What's the end behavior? What are the intercepts? All of that stuff. That was polynomials, right? Now, we're dealing with exponential functions, so the variable is in the exponent. So is this exponential? Variable in the exponent? How about here? Is the variable in the exponent? No. Base. Variable in the exponent here? Yeah. Variable in the exponent? Yeah, but it's also in the base. So remember, the base, c, has to be a constant. 1/4 to the t? Yep. The negative of 3 to the x? Well, no, right? Because it's got to be greater than 0, so that negative means. But wait a second, it's not really the base is really positive 3. We're saying it's the negative of. So yeah, okay, we'll go with it is, right? Because it's not negative 3 to the x, it's the negative of, that's the difference though, right? Negative 3 to the x is going to be flipping back and forth with x, right? When x is odd, it'll be negative. When it's even, it'll be positive. This thing is just always negative, right? Like 3 to any value is going to be some positive thing, then this will just make it negative. Anybody start out in 30-1? There's one. Okay, so yeah, a couple. So I mean, you would recognize this as simply that's just a reflection in the x-axis, right? Okay. And we did that in a little bit of that in 20-1, 20-2. How that's a reflection. So it's an exponential function. It's just reflected in the x-axis. Okay. That's a transformation. we'll look at that and sort of see what does it all mean. So basic exponential functions where c is greater than 1. So for the exponential function y equals 2 to the power of x and y equals 4 to the power of x, complete the table of values below and sketch the graphs on the grid shown. Okay, so let me shrink this down so it's visible on one page. What do you say, 125? Yeah, good enough, eh? Okay, so we're doing, move it away, 2 to the power, what's 2 to the negative 3? 1 over 2 cubed, or 1/8, right?
Yeah.
Okay, so 1/8. 2 to the negative 2, 1 over 2 squared, or 1/4. 2 to the negative 1, 1 over 2 to the 1, 1/2. 2 to the 0, anything to the 0? 1. 2 to the 1, 2. 2 squared, 2 cubed. All right, let's do this table. 4 to the x, where x is negative 2. 1/16. 4 to the negative 1. 4 to the negative 1/2. 1/2, right? It's 1 over the square root of 4, right? 1/2. 4 to the 0. 4 to the 1/2. 2, right? Square root of 4. 4 to the 1 and 4 squared. Okay, so let's sketch these. We'll do y equals 2 to the x in red. We'll do 4 to the x in green. Okay, so negative 3 is 1/8. So that's going to be down there pretty low. Negative 2 is 1/4. All right, that's a quarter. Negative 1 is 1/2. 0 is 1. Okay, that's easy. 1 is 2. 2 is 4. 3 is 8. And we can actually do 4, right? 2 to the 4th would be 16. Okay, so what's this graph look like? It's doing this. It's climbing up that way. And it's just going to get lower this way, right? Negative 4 will be 1 over 2 to the 4, 1/16. Negative 10 will be 1 over 1,024. Getting really, really small. And let's label this, right? This was y equals 2 to the x. Let's do 4 to the x. So negative 2 is 1/16. That's going to be like a lot lower. Negative 1 was 1/4. That's like about there. And negative 1/2 was 1/2. So that's going to be about there. 0 is 1. So these guys are right on top of each other. 1 is 4. And 2 is 16. So it looks like it's going to climb a lot faster. But on this side, it's going to fall much faster. So the green one is y equals 4 to the power x. Okay, so take them all, write them down, become familiar with, these are exponential functions, right? You got a constant for the base, 2 or 4, and your variable is in the exponent. On the same grid above, sketch the graph of y equals 3 to the x and 5 to the x. Okay, so let's do 3 to the x in blue. So where's 3 to the x going to be? Is it going to be in between 2 to the x and 4 to the x? Will it be to the right of 2 to the x? Or it'll be in between, right? Because we know that when x is 1, you're going to get a 3. When x is 2, 3 squared is 9. Okay, now in between here, negative 1 will give you 1/3, right? Remember, we got a half here and a quarter here, so a third is going to be in between. And 0 is still going to be, or sorry, when x is 0, you're going to get a 1, right? 3 to the 0 is 1. So it's in between. and it's also in between here. So that's y equals 3 to the power of x. And 5 to the x, I guess all we got left is purple. So is 5 going to be in between 4 and 3, in between 3 and 2, to the right of 2, or to the left of 4?
So the right of
Well, so let's throw in a 1. 5 to the 1 is going to be 5. Right? And then 5 squared is 25. That's like way off already. 5 to the 0 is 1. So we're going to go from here to here and then up. So this is y equals 5 to the x. And is it going to be below all of these guys? So at 1 it's going to be 1/5, right? And 4 was 1/4. So it's actually to the left because it climbs faster than any of these guys here, but it falls faster over here, right? Because -2, that's 1/25. -3 is 1/125th, right? You get really, really small values really quick, same as you get really big values really fast. Okay, so it's the lowest 5 to the x. So these kind of go, this is 5, 4, 3, 2, right? Or they go down, 2, 3, 4, 5. And as you go to the right here, your values are getting smaller, right? Or as you go this way, your values, and the easiest way to do it is just take at 1, what is it, right? It's 2, that's 2 to the 1. That's 3 to the 1, that's 4 to the 1, that's 5 to the 1. Okay, if we have 10 to the 1, you know, we're here. 10 squared is 100. You go 10 up to 100. It's going to go really quick. Really quick. For y equals c to the x, where c is greater than 1, as the value of the base c increases, the graph gets. So what we're going to do is graph gets steeper, right? Goes up faster, so we'll call it steeper. Complete the following statements. For y equals 2 to the x, every increase of 1 unit for x corresponds to the y value. So, whoops, wrong way. So 2 to the x, this is the red one, right? So I go from 1, 2, I go to 2 here, this goes to 4, I go to 3, this goes to 8. So 2 to 4, 4 to 8, what's happening? Y value is doubling, or increasing by 200%. For 3 to the x, every unit of 1 corresponds to the y value. 2 to the x doubles, 3 to the x triples. So it's tripling. Or an increasing by 300%. Yeah, we should, but we're not going to.
Let's just do it. Let's just.
I know, that's it. Do it. Basic exponential functions.
Call it a day. Yeah, just stop.
No. We'll do this tomorrow. I got like videos I gotta put together stuff. I want to do this now. For the exponential function, y equals 1/2 to the x and 1/4 to the x. Complete the table of values and sketch the graphs on the grid shown. Okay, I'm gonna do the values for you. So 1/2 cubed is going to be 1/8. 1/2 squared is 1/4. 1/2 to the 1 is 1. 1/2 to the -1, flip the half, it becomes 2. So this is 2, this is 4, this is 8. These guys, this is 1/16, this is 1/4, 1/2, 1, this is 2, this is 4, this is 16. Going to graph this one in red. So I've got -3, 8. Got really high values going here. -2 is 4. -1 is 2. 0 is 1. That's supposed to be a 2. 0 is 1, and then we've got 1/2, 1/4, 1/8. Draw the line. And this guy will do in green. So negative 2 is 16. Negative 1 is 4. Negative 1/2 is 2. Then we've got 1 and a half. We've got half, and then we've got a quarter, and then we've got 1/16. One third to the x is going to fit in between them. Okay, because negative 1 will be a 3, and negative 2 will be a 9. So it's going to go in between there and in between here. And 1/5 to the x, well, negative 1 is going to be a 5, so it's going to be steeper here. And it's going to go lower here. Okay, so we'll finish this and we'll go back to the diagram. For y equals c to the x, where 0 is between, as the value of the base decreases, so decreasing, right, what have we got? So decreasing, so we've got 1/2, 1/3, 1/4, 1/5. As we're going down, it's getting steeper. Graph gets steeper. For y equals 1/2 to the x, every increase corresponds to the y value halving, which is really halving, or decreasing by 50%. For 1/4, it's going to be quartering, or decreasing by features for the basic y equals c net. Don't worry, we still got 4 minutes. We can finish. Don't worry. We're going to go over this again tomorrow, but with a different sheet, right? Or not a different sheet, but a different thing. So we will have seen this. Don't worry. You're going to see it again tomorrow, so we'll go back through it. But the domain is x belongs to the reals, and the range is y is greater than 0. You can't hit 0. You can get really small, right? Like you do 2 to the negative 10 and get 1 over 1,024. The y-intercept is 1, and there is no x-intercept. The graph has a horizontal asymptote with the equation y equals 0. If c is greater than 1, the shape of the graph is like this. As you read from left to right, the graph is increasing. And the graph gets steeper as the value of c increases. This is a growth function, right? It's getting bigger. If c is between 0 and 1, then the graph is doing this. As you read from left to right, it's decreasing. And the graph gets steeper as the value of c decreases. This is a decay function, so things are getting smaller. And then there's the functions if you want to see them.